Hello and welcome to this grade 9 physics lesson. The topic for this video is refraction of light. To begin with, recall from the chapter Reflection of Light that light travels in a straight line, and we can represent a ray of light by a straight line with an arrow pointing in the direction in which the light is traveling. So what is refraction? Refraction is the change in direction of light caused by a change in its speed when it travels from one medium to another of different optical density. So what do we mean by a different medium with different optical density? Light can travel through a medium which is transparent, such as air, glass, water, or oil. So if we have a glass block, it is surrounded by air. Glass is optically denser than air. This means that light travels slower in glass than in air. So a ray of light moving from air into the glass block will have a change in its direction. Let us look at some effects of refraction. So here we have a beaker, and we're going to place a smaller beaker in this beaker. And watch what happens when oil is poured into the small beaker until it overflows. You can see that the small beaker, when surrounded with oil, becomes invisible. This is an effect of refraction. The light moving from the small beaker into the oil and then through the large beaker into air changes direction so that the small beaker becomes invisible. So because of refraction, we cannot see the small beaker which is in oil. Here is another experiment that can show some effects of refraction. So if we place a straight wooden rod in a beaker of water, you can see that the wooden rod appears broken. And looking from the top, you can see that the wooden rod appears bent. So due to refraction, objects appear broken or bent when partially submerged in water. We can demonstrate refraction of a ray of light by using a source of laser light, shining the laser on a sheet of paper. We can see that the ray of light moves in a straight line. Now watch what happens when a glass block is placed in the way of the ray of light. So the light is incident in the glass block in this position and exits the glass block along a different line. This means that the light moved inside the glass block in this direction. So you can see there's a change in direction of the light as it moves from air through the glass. So we see that light changes direction at the boundary between the air and the glass. And then when it reaches the boundary between the glass and the air, it changes direction again. Note that the light will not change direction if the ray of light is perpendicular to the boundary between the two media. In this case, the light is not refracted and moves straight through the glass. This can be shown again with a ray of laser light, which is shown perpendicular to a glass block, and as you can see, no refraction occurs. So, how do we know in which direction does light refract? There are two cases to consider. First, when light moves from one medium into another medium of higher optical density, it bends towards the normal. So here we have a ray of light incident from air into glass. That is, it is moving from a medium into another of higher optical density. At the point where it touches the boundary between the two media, we draw a line perpendicular to the boundary called the normal. This line is at 90 degrees to the boundary, and instead of moving in the same direction, the ray of light is going to approach the normal. We say that it bends towards the normal. Another example would be a ray of light moving from air into water, which is optically denser. Again, we draw a normal at the boundary between the two media, and instead of moving in a straight line, the light will bend towards the normal. Let us look at a final example. Again, we have light moving from air into glass. The glass is optically denser, so the light is going to bend towards the normal. The second case to consider is when light moves from one medium into another medium of lower optical density. In this case, it will bend away from the normal. As an example, we can consider a ray of light moving from glass into air, which is of lower optical density. Again, at the boundary between the two media, we draw a normal line, and instead of moving in a straight line, the light will move away from the normal. This occurs because air has a lower optical density than glass. Another example would be a ray of light moving from water into air. So again, instead of moving in a straight line, the ray of light will move away from the normal as it moves from the water into air. Let us now look at a general diagram illustrating refraction of light. So here we have a ray of light moving from medium 1 into medium 2. So the perpendicular line drawn at the point where the light exits medium 1 is called the normal. The ray of light moving towards the boundary between the two media is called the incident ray, and the ray of light that exits the boundary is called the refracted ray. The angle I between the normal and the incident ray is called the angle of incidence, and the angle R between the normal and the refracted ray is called the angle of refraction. Let us now use some ray diagrams to explain some effects of refraction. We have seen earlier that a stick appears bent or broken when seen by an observer if the stick is partially immersed in water. Let us consider a point X at the end of the stick. And we are going to use ray diagrams to show the position of the image of point X that the observer will see when looking at the stick. In other words, the observer will not see point X in its actual position, but will see an image of point X. Rays of light coming from point X move in every direction. However, to determine the position of point X, two rays of light are enough. Each ray of light will be refracted as it moves from the water into air. Recall that the rays of light will bend away from the normal since air has lower optical density. So these two refracted rays will now enter the observer's eye, and the observer will see point X in this position labeled X dash. Similarly, we can determine the positions of other points on the stick. And you can see that all these points appear closer to the surface of the water. So for the observer, the stick appears bent. Due to refraction, objects underwater appear closer to the surface. An example would be how swimming pools appear less deep than they actually are. Another effect of refraction is the separation of light into its constituent colors when it passes through a prism. As you can see in this picture, sunlight enters the prism and is separated into its constituent colors. This happens because each color of light is refracted through a different angle as it passes through the prism. We can see this effect in daily life by the formation of rainbows. A rainbow is formed when sunlight is reflected and refracted through water droplets in the atmosphere. This series of reflection and refraction separates the sunlight into its constituent colors, causing a rainbow to be formed. To summarize what we have learned so far, refraction is the bending or change in direction of light caused by a change in its speed when it moves from one medium to another of different optical density. When light moves into a medium of smaller optical density, the speed of the light increases and it bends away from the normal. When light moves into a medium of higher optical density, the light will slow down and will bend towards the normal. Refraction can be experienced in everyday life through these effects. Bodies underwater appear closer to the surface than they actually are. Objects partially submerged in water appear bent or broken. Rainbows are produced by the refraction of sunlight through water droplets in the atmosphere. And finally, a common use of refraction will be through the use of magnifying glasses. When light is refracted through the lens of the magnifying glass, objects seen through the lens appear larger. We have now reached the end of this lesson. Hope this video has been helpful. Thank you for your attention and see you next time.